Okay, we are to solve the following equations. In the previous video, we saw that sine theta is equal to cos 90 minus theta, and cos theta is equal to sine 90 minus theta. We are going to be using this to solve the equations. So let's start with the first one. Cos alpha is equal to sine 40 degrees. We will write this as though this does not exist. So we have cos alpha. If I want to express it like this, it should be sine 90 minus alpha. We're writing this just to look like this. Okay, so all I'm doing is I'm picking one part here and I'm writing it to suit what I have here. Now, because the left hand sides are the same, the right hand side too are the same. You know, there was a previous video I did where I said if you have something like a equals x and the same a is equal to y, it's like saying Taiwo's age is equal to Ayo's age. The same Taiwo's age is equal to Dapo's age. That means Ayo and Dapo are the same in age. So the same thing here, these are the same, hence these are supposed to be the same. So that means that sine 40 degrees is equal to sine 90 minus alpha. So since they both have sine, we have 40 degrees to be equal to 90 minus alpha. If I bring this alpha to the other side, I'll have alpha to be equal to 90 degrees minus 40 degrees. And that gives me what? 50 degrees. And that is it. And if you check it, if you put 50 degrees here, and this is 40 degrees, by the time you combine the two of them, you should have 90 degrees. That tells you that you are correct. Let's try the next one. All right, here we have sine 2 theta to be equal to cos 3 theta. Like I said, keep one side. So you have sine 2 theta. We write it to suit this. So that means it's like I'm having 2 theta here. So this side is supposed to be cos 90 minus whatever I have here, which is 2 theta in this case, 2 theta. All right, so these are the same. So I'm going to equate this, and I'm going to have cos 3 theta to be equal to cos 90 minus 2 theta. These are the same. Equate this side, and that's what we have done. So since they are equal to themselves, that means that this and this are equal to themselves. So that gives me 2 theta to be equal to 90 minus 2 theta. If I bring this to the other side, that's collecting like terms, I will have 5 theta to be equal to 90 degrees. And divide both sides by 5, divide this one by 5, then you see that this will cut this, and my answer will be theta equals 18 degrees. Let's try the third one. We have sine phi minus cos phi equals 0. All right, it's not looking like the equation, and we are supposed to have two sides to it, so I'm moving this to the other side. So I have sine phi equals, this is moving and giving me cos phi. So we write one part, and that gives me sine phi to be equal to, as if this does not exist, it's supposed to be cos 90 minus the phi. Okay, so these are the same. Equate this, and that gives you cos phi equals cos 90 minus phi. You know what to do next? So equate this, and that gives me phi to be equal to 90 minus phi. When this comes here, I'm going to have 2 phi equals 90 degrees, and when I divide both sides by 2, my side is going to be 45 degrees, and that is it. Now, solving the last one, we have cos gamma equals sine gamma minus 10, and that's, I will keep one side constant. See, gamma equals, is supposed to be sine 90 minus gamma, and when I do that, I will have this side to be equal, and that gives me sine gamma minus 10 to be equal to sine 90 minus gamma. Okay, so when you equate it, you have gamma minus 10 equals 90 minus gamma. So collect like terms, this comes here and gives you 2 gamma, which is equal to, when this 10 moves there, 100. And when you divide both sides by 2, your gamma will be equal to 50 degrees. That is how to solve it.